Fighting Blindness Canada's Viewpoint is an education series that brings you the latest in vision research presented by health experts from across Canada. The session you're about to watch is a recording. To learn more about the research we fund and upcoming programs and events, please visit our website at fightingblindness.ca. Viewpoint is proudly presented by Bayer and supported by Abbvie, Apellis, Astellas, Beacon Therapeutics, Biogen, Johnson & Johnson, Novartis, and Roche. Thank you for watching. We hope you enjoy this session and share your thoughts with us in the comment section below.
This is a really exciting session. This session is really designed for all of you in the room. It's a Q&A, a question and answer session. And we're really fortunate today because we have one of my personal favorite people in the room, Dr. Brian Ballios. Yeah, of course, absolutely. So I've had the privilege of working at Fighting Blindness Canada for just over 15 years, and I've known Dr. Brian Ballios the whole time. And not only is he an extraordinary human being, but he's a spectacular clinician and researcher. And I am going to read a bit of his bio because there are some people, surprisingly, in this room that may not know all of this, but I think it's really incredible. So I'm going to read to you here. Dr. Brian Ballios is a fellowship-trained clinician scientist with a focus on medical retinal disease and subspecialty in inherited retinal diseases. So for folks in the room with inherited retinal diseases like RP, for example, it will be wonderful for you to be able to ask some questions. He's also an assistant professor in the Department of Ophthalmology and Vision Sciences at the University of Toronto. He holds an appointment as a clinician scientist at the University Health Network and the Donald K. Johnson Eye Institute, and is a staff physician at Sunnybrook Health Sciences Center and the Kensington Vision and Research Center. Dr. Brian Ballios is also a scientist at the Krembil Research Institute, where he has a laboratory investigating the mechanisms of acquired and inherited retinal disease and the development of new stem cell-based therapies. He's obtained his MD and his PhD degrees at the University of Toronto in a combined MD-PhD program. So I'm sure there's probably more and more to add to that bio, but I want to turn it over to Dr. Brian Ballios. That's why you're all here today, to be able to ask your questions. I know that there's some mic runners in the room, so all you have to do is put up your hand and someone will come right to you. Please speak loudly and clearly right into the microphone because we are also streaming live and recording this session, and we don't want anyone at home to miss your great questions and Dr. Ballios' great answers. So I'm going to open it up. Is there anyone out there? You know what? No, I'm going to take the first question because I want to get things started here. And I think this is a really important question, and I think all of us, would love to hear the answer to this. Dr. Brian Ballios, why did you decide to specialize in inherited retinal eye diseases?
Wow, that's a great first question. Thanks, Jamie, for that really kind and generous introduction and for inviting me to be here. I love coming to Fighting Blindness Canada events, and I've been coming to Viewpoint and incarnations of that for a very long time. So it's really a pleasure to be here, and I hope we have some questions today that I can try my best to help to answer. I don't promise to be able to answer every question. But to start with your first question, which is a great one, why am I so passionate and why am I interested in continue to practice in the space of inherited retinal disease? Well, I've always been interested in how things work, and as a young person in training as an engineer, I was always interested in the mechanisms and how things worked. And in my scientific training, I liked to try to find out how the most challenging diseases in ophthalmology would manifest and affect vision. And it led me to some research looking at the molecular biology and stem cell biology of the retina and how the retina develops. And I became very interested in the mechanisms of disease. And in my training, I had the opportunity through organizations like Fighting Blindness Canada to meet many patients who are suffering from these conditions that affect vision, that are that are genetically determined and that in many cases are inherited within families. And as I went through my training and spent more time interacting with these people and these families, I came to realize that these are some of the most challenging conditions in all of medicine for people to live with. And it's a field where for many years, decades, even before I started my practice and even before I started my interest in ophthalmology, where as far as eye diseases were concerned, there wasn't, I think, as much attention paid to trying to find solutions, to trying to find cures to these conditions. Part of the challenge was being able to identify what the specific problem was with these conditions, being able to understand the genetic basis of disease. But I'm very fortunate in the time that I've had to practice to see a lot of that understanding come through and a lot of the focus shift towards treatments and cures. And that's really the emphasis of a lot of research right now is what can we do about these conditions? And I think that's a really, as someone with an engineering mind and with a background in engineering, a really exciting time to work in this field. So that drives my passion. But the patients that I have, who I see in clinic and every day, and as time goes on, they always remind me about just what a needful area this is in ophthalmology, and how we really need to be pushing forward whatever new treatments we can find for these patients and families. And so it's my patients that remind me every day why I got into it in the first place. Yeah.
That's incredible. Thank you so much, Dr. Ballios. So it's a really unique sort of, I call him a bit of a rock star in my own words, because he's able to see patients through his clinic and have that firsthand experience, just as Dr. Ballios said, but also have that protected research time in his laboratory is just a wonderful opportunity for us to ask Dr. Ballios some questions related to IRDs. So is there anyone in the room that has any questions? We have a question right there, gentleman with the hat. Thank you, Kathy.
Thank you. Hello. Hello, Dr. Ballios. Good to see you. My name is Roman. I'm almost 70 years old. More than half of my life, I have this retinal disease. In the beginning, I was told I have Stargardts. Then I was told I have a mixed RP. Now, because I'm aged, now it's called macular degeneration. My question is, would I live to see the day where I will have the cure for my vision? Thank you.
Well, thank you for that question. I'm humbled to hear about the journey you've been on. You took us back and explained that, in the past you'd been given one diagnosis and then different diagnoses, and now another diagnosis, and Stargardt disease in the past and RP, and that's something I hear a lot from my patients as the years go on. The biggest challenge in the past was trying to identify what specific retinal condition the patient had. And sometimes it's not always obvious what that particular condition is. And for many years, the focus of research has been on trying to define the problem. And even before coming to try to do research on where the solutions lie, how can we find the causes of these conditions? How can we identify them and better characterize them? And I imagine in the past, in your experiences with eye doctors, there's been times where the diagnoses from different eye doctors has differed from one time to another in the visit. And I think we're reaching a point in our understanding of these conditions like yours where we're much better at identifying the specific cause. And so a lot of attention in the last 15, 20 years has turned towards what can we do about it, and treatments and cures. And the research has developed to a place, and you've probably heard earlier today, where for some specific genes, there are some very good therapies and drugs being developed that are either in clinical trials or now in clinical practice for some patients. And we hope to see a lot more in the coming years. But that's the biggest question, like you asked, for my patients who are older, in their 60s, 70s, and 80s, is there going to be a time for where there's actually a treatment and a cure for me? But the truth is, I don't think anyone can answer that question with a specific date and a time. I got into this field to do research because I imagine and visualize a future where we do have those cures, certainly in my time and my practice, and I have seen new treatments. I don't know if they'll take the form of treatments that cure or reverse disease, but I know of a lot of new drugs that are being tried for conditions like Stargardt disease that you mentioned, clinical trials of drugs looking to slow down or stop progression of disease. For some patients that have lost a significant amount of vision, that may not be the most encouraging, because they may say, well, I don't want to slow down, I want to get back what I had before. So what I like to say to my patients is, you're on a path in your life with your condition, and science is also on a path, and at some point you're going to converge. But how long does that runway look like? Is it 10 years? Is it 15 years? And is that going to be something relevant to you in your life? That's very hard to say. But for those patients who have had a diagnosis made 10, 15 years ago of RP65 disease, for example, for Leber's congenital amaurosis, now they're being treated with gene therapies. And I think back then, 10, 15 years ago, we wouldn't have been able to say to them in a room like this, yes, there's going to be a treatment for you. And yet, 10, 15 years later, here we are sitting here knowing these patients can get treatments. So I'm always optimistic that, over the years to come, in the next decade, we're going to see many, many new treatments for inherited retinal disease. But to say it specifically for one type is very hard, because many researchers are making efforts along different lines. I know that can't give you a specific answer to your question, yes, no, and that's what you want, and that may be a bit of a hand-wavy way of answering it, but it's a tough question, and it deserves a fair answer.
Well, I'd like to just jump off that, Dr. Ballios, and could you maybe talk a little bit about why genetic testing is important when it comes to inherited retinal eye diseases, to getting that diagnosis?
That's a huge point. So genetic testing, we have to remember, is not something that's been available to us for very long. For many patients who were diagnosed with their condition in the 80s and the 90s, the 1980s and the 1990s, genetic testing was not available to them. The first human gene mapped for an inherited retinal disease, rhodopsin, associated with retinitis pigmentosa, was first discovered in 1990. And through the 90s, more genes were discovered, and then with the mapping of the human genome in 2001, there was this explosion of our ability to identify genes. So if you think about all of the studies that have been going on around patients and their diseases and these processes, these were clinical studies that weren't based on their specific genetic type. And we couldn't even imagine beginning to design therapies aimed at specific genes well into the 2000s as we started to discover these genes. There's been a huge proliferation in the number of genes that we've discovered. Now over 300 to 350 genes that we know are associated with inherited retinal diseases. That growth in our knowledge over the last 10, 15 years has spawned new research projects and new efforts to try to design therapies for these different conditions. And so as much as possible, I think it's important that to drive forward a patient's own understanding of their condition, and also to understand where they fit in the larger research effort, beyond what it's important to understanding how these conditions are inherited in families. Genetic testing is very important. And our accuracy with genetic testing has been getting better and better. So if someone has had genetic testing 10, 15 years ago, which didn't yield a result at the time, they couldn't have the gene identified, I think it's very important at this time to think about having that testing redone.
That's great. Thank you. Monica, I think there's a question in the back.
Hello, my name is Joseph Sideros, and I wanted to know what is the percentage of people with RP in Canada?
Hi, Joseph. Nice to see you back there. I think it's a little bit hard to determine an exact percentage across the entire country. We more think of it in terms of incidence, in terms of how many new patients or what fraction of new patients we might discover with retinitis pigmentosa. And rates vary by population, but can be anywhere in some populations from 1 in 4,000 people to upwards of 1 in 7,000 people. And a lot because this is a genetically determined condition, a lot depends on your particular genetic background, where your family's from, and what part of the world they've come from originally, and that family structure. There are some places and some communities around the world where the incidence of retinitis pigmentosa is much higher than if you were to pool everyone together. So when I have a patient in front of me, it's very hard to say, let's say the average number across the country doesn't have as much meaning, because Canada is a very multicultural country. Patients people in our country have come from a broad variety of places, and their families from a broad variety of places around the world. So, an incidence like that of 1 in 4,000 to 1 in 7,000 might be one way of looking at that kind of number. But that could be much more common in one population than another.
Great question. I see a few hands, Monica, just beside you. I see a gentleman. Okay, great.
From the research that you're doing, is there anything that will be available on the market in the near future, or any interesting aspects associated with it?
I think I missed, did you miss the first part of the question? The very, very first part. Do you mind repeating your question, please, sir?
From the research that you're doing, is there anything that we should be paying attention to that will be coming onto the market or available within the near future?
Sure. So I would say from some of the research that I've been involved with, I would say that some of the drugs that have been focused on neuroprotection, that is protecting the health and preserving the health of light-sensitive cells in the retina, in the eye, have shown a lot of promise in recent clinical studies, and many of them have advanced to quite advanced stages of clinical trials. And there's various examples that Fighting Blindness Canada has given some information on before to patients. Drugs like N-acetylcysteine, which is in a phase 3 clinical trial sponsored by the National Eye Institute. There's other companies that are focused on medications that can be injected into the eye to try to preserve the health of light-sensitive cells. And some of these are in quite advanced phases of clinical studies, so the neuroprotective agents. And one of the other exciting types of therapies is gene therapy, which you've probably heard some about earlier today. And one of the challenges of gene therapy is that a lot of gene therapies right now, efforts are focused on designing therapies for very specific genes, individual genes that affect one piece of the pie, one piece of the one group of patients, perhaps a small group of patients out of all the patients suffering from inherited disease. But a new gene therapy approach called optogenetics seems to be a very promising approach to potentially help patients who've lost a significant amount of their vision, who might potentially regain vision through a gene therapy approach that could, in principle, be helpful for a broad variety of genes. So these very broad approaches, some of which are in phase 2 and phase 3, in other words, almost final phase clinical trials, I think we're going to see a lot of these become available over the next 10 years for patients. And whether it'll be relevant to an individual patient will depend a lot on how their vision is at that time and how the retinal health is. And so we'll have to see. But those are some of the ones that I think are closer to clinical application. One of my areas of passion is stem cell research and trying to replace the light-sensitive cells in the retina. In many ways, this is a very challenging approach because it depends on designing a living therapy that has to survive and live after you transplant it into the eye. And there have been a lot of efforts to try to make a robust stem cell therapy, and I still believe that that's in the future for us. And there have been examples, certainly in other tissues of stem cell therapies being very effective, like bone marrow transplantation and allogeneic stem cell therapy. But for the solid tissues, for the solid organs like the eye, stem cell therapy hasn't yet given us a treatment. But I think that we're seeing a lot of continued research and effort in that. So I think the gene therapies and some of these drugs are a little further ahead. We'll probably be seeing those sooner over the next 10 years.
That's great. And I think if you could speak to, Brian, just on that same point, how research in one specific area and the learnings can lend to other IRD research that could benefit other groups of, is that something that you think is accurate? Just focusing on one area can lend to learnings and discoveries in other areas of IRD?
Well, yeah. I mean, for many years, I've been focused on how to design better stem cell therapies to try to replace light-sensitive cells in the retina. These are cells that are important for vision, and when they're lost, we lose vision, and stem cells hold the promise of replacing these cells. But through my own research and that of others in the stem cell field, we've discovered that research can actually give us a lot of insight into other things. So we can learn from that research about the mechanisms of how diseases work. So we can discover a gene, but we might not know how it causes the disease in the retina. What's the way in which it interacts with other proteins and other cells in the retina? And the stem cell research, studying that through using those techniques, has also given us a lot of insight into those diseases, and in some cases has led to new candidate drugs that are being tried in clinical trials. And so some of my research in the last 5 or 6 years has shifted over to using stem cells to understand the basic mechanisms of the most challenging retinal diseases, ones that we don't yet understand completely the mechanism for, in the hope that better understanding of that mechanism will show us new drugs. And for example, we have a project working on Usher syndrome. And there's a lot we know about Usher syndrome and the Usher gene, but there's a lot we don't know. And there's been a lot of attention in clinical studies and clinical trials to try to make drugs for Usher syndrome and for the retinitis pigmentosa that comes with Usher syndrome. And not all of those efforts have been successful. And as a group of researchers in the field, we think that maybe some of that lack of success has had to do with maybe we don't understand the disease as well as we thought we did. And maybe there's better drugs we could design to treat that condition. And so in my lab, we have a project focused specifically on Usher because it's a very common cause of retinitis pigmentosa, and maybe we don't understand it as well as we thought we did. You know, it's challenging in the field because you think to a time in the COVID pandemic recently, for example, where many researchers across the world stopped what they were doing and turned their attention to focus on developing a vaccine for COVID. And I imagine, wouldn't it be wonderful if there's a way we could all stop everybody doing what they were doing in their own labs and turn all of their research attention towards inherited retinal conditions? But it's not realistic to think they could. There's many talented researchers in Canada, the United States, around the world who are working on these new treatments. They'll come in time as they will for other conditions.
Yeah. That's great. Monica, thank you.
Thanks very much for coming and speaking with us, Dr. Ballios. My name is Glendon, and as I think I mentioned earlier, I was originally diagnosed with RP, and after being confirmed as having choroideremia through giving a blood sample, I'm now in my 60s, and I guess I have 2 questions. The first question is, I have a lot of questions about what's going on in my eyes today, but I no longer have a specialist. I've been doing research for the last year, and I can't for the life of me find or be able to find who might be a good recommendation for choroideremia for my particular problems. In Toronto, I would dearly love if you're able to give me at some point a recommendation. Even you at the U of T sounds like a great choice. But one of my problems that concerns me, and the CHM group in the States I've joined, nobody in the group understands what I'm experiencing, and that concerns me. The flashing lights, which I had earlier, and as I was diagnosed with RP, have gotten worse. In fact, now it's covering everything. I'm not in the dark. Everything is bright, like I'm looking outside through a net curtain, orange and green flashing lights everywhere as a net over everything. And I also feel like I'm in a fish tank. And if I stand up straight, my lights, there's another layer of lights in the back that are shooting upwards like tiny little millions of these little sprays going up at 11 o'clock, not 12 o'clock. That concerns me, I figure. Human physiology, you'd think that everything is mathematical, and if it's something that's supposed to help me with my balance in my brain that I'm seeing because of my choroideremia, I'm perceiving these lights going upwards, but nobody can tell me. I'm wondering if I should be going and getting an MRI or seeking other specialists outside of choroideremia to see if there's anything else going on. But that's my long story. I guess in the end, I think it's important for everybody to have someone to communicate with about their issues, a good specialist that is knowledgeable about their own disease that they could speak to. I'd dearly love to find that person in Toronto today, but having difficulties. So thank you.
Well, thank you very much for your comments and your thoughtful description of how things have changed for you, through your life and even more recently. I agree with you completely. I think it's really important that patients with rare eye conditions like retinitis pigmentosa and choroideremia, and I say that rare because it doesn't feel rare. That term doesn't feel rare to us in this room, and it certainly doesn't feel rare in my practice. But I recognize that for my colleagues in comprehensive ophthalmology and optometry, a condition like choroideremia or retinitis pigmentosa may feel very rare in their practice. They might only have a handful of patients who have those conditions. So I agree. I think it's important that you have an eye care provider who recognizes and understands the condition. And if you're looking for specific things, I'm sure we can connect offline through Jamie and FBC about people in the city, including myself, who see patients like that. The symptoms, the visual phenomena, what you've described as seeing, the lights, the movement, the change in shape and the unusual patterns in the vision can sound quite unusual to an eye care provider who might not be familiar with patients who suffer from these disorders. But I certainly have a number of patients with choroideremia and RP who describe phenomena in their vision and lights and movement the way that you've described it. Patients at your age as well, and older or younger, but it depends a lot on what stage of their condition. Nothing stays the same in the eyes with these conditions over time, and new visual phenomena can appear as patients journey through their life with these conditions. We don't understand everything about what causes these symptoms, especially the ones of the flashing and moving lights. But there is some appreciation now, I think, in some of the literature that we think that some of these visual phenomena may be related to signaling between cells of the retina. And we know that in a retina that's not suffering from a genetically determined condition or an IRD, in a retina that's full of healthy light-sensitive cells, we know that there's always crosstalk between light-sensitive cells in the retina, between areas of the retina, and that signaling is happening continuously while we're awake, even when we're asleep. The electrical impulses and signals are moving in waves throughout the retina. And our brain learns to shut out these signals when we're very young. And it suppresses these signals, and we don't notice these visual phenomena. They're suppressed. And one school of thought is that one of the reasons that these visual phenomena, flashing, moving lights, become more prominent as a patient progresses through their condition is that now there's areas of retina that are still relatively healthy and areas that are not. And there's some imbalance now in that electric crosstalk, that signaling between them. And that can be now perceived by the brain as visual phenomena, as moving lights or flickering lights or spots within the vision. And sometimes these visual phenomena can be very alarming to a patient. But it's worthwhile talking and describing in detail, as you've done some of, but spending even more time talking with an eye care specialist about these to understand if they seem to be in keeping with what we understand to be, common for these conditions in the eye, or if they represent something that sounds unusual and would be worth getting checked out, as you mentioned, with an MRI or some other consideration for something outside of the eye. So I appreciate the point you've made, and I think that you've made a very important one, because sometimes my patients will call me up and say, I've noticed something brand new, and I went to my regular eye doctor that I typically see for my glasses or in my community, and they don't really understand, they're not really able to tell me what's causing what I'm experiencing and whether I should be alarmed about it. So I appreciate you sharing, because I don't think people talk enough about some of these less well spoken about symptoms. A lot of people talk about the negative symptoms that happen. We call them negative in medicine, the things that are absent, the absent symptoms. I don't see as well at night. I don't see as well in my side vision. I don't see as well in my center vision. But people don't talk about the positive phenomenon. That we call this positive phenomenon medicine, the things that are new, that are stimulatory, like bright lights, flashing lights, and things that move in the vision. And those deserve attention as well.
We have a couple questions from online, so let's go to one of those. Dr. Ballios, what kind of advice or guidance can you offer patients who are children and teens and their families who are concerned about their future with RP? It's a challenge in terms of what they will or will not be able to see, but also how these young people will fare socially.
Yeah, a diagnosis of retinitis pigmentosa, or any eye condition, to be honest, any eye condition in a young person, a child, an adolescent, a teen, even a young adult, is a very challenging diagnosis and a very difficult time in a person's life and a family's life. And I think it's important that through that careful assessment you have with your eye doctor, there's emphasis placed, of course, on the things that are difficult, but also to be reminded that even in conditions like retinitis pigmentosa, often there are things that are still very strong about the vision, and that if it's something that's typical for RP, then not all patients are the same, but in many young people, the center vision and the field around the center vision remains quite strong, even in young adulthood and adolescence, and then through as the years continue. The center vision can remain quite strong for a long time, and that's important to emphasize just what those things are that are very good and helpful about the vision for a young person. And one thing that I tend to focus on in those first encounters, either the first or second encounter with a new diagnosis for a young adult or an adolescent, is to focus on what things who should we be letting know about this problem, because these conditions are invisible. They exist inside our eyes, but there's no obvious challenge outside of the way perhaps a person might have trouble in different circumstances, like maybe not being able to play with their friends in the dark, or be able to find their way to a night class if they're a young adult at college, for example. And these children can be nervous about sharing that with their friends or with their teachers. And I think it's really important that young people be set up with the tools they need to be successful. And so we spend a lot of time with families trying to figure out, what are those things? Do they need to be set up with an individualized education plan, for example? If they have a condition that means that it's hard for them to find their way in the dark, should they be not taking classes or extracurriculars as much as possible at nighttime, for example, and avoiding that? If they have some trouble with their center vision as a result of this, or glare, should they be sitting in a part of the classroom that's helpful to them? Should they be sitting in should they be given extra time for doing their tests or their reading? I mean, young people won't speak up about these things. They don't want to stand out relative to their peers. But I think there's sensitive ways about advocating for young people, certainly as a provider myself, and I think as a family. And so I think, trying to enlist as much help as possible from places that are familiar to the person. School, for example, or sports, as coaches, for example, if they're into extracurriculars and sports teams. So we spend a lot of time in the clinic thinking about those aspects of things as well. I try not to bombard a family with too many resources at once. I think it's probably my job to listen as much as it is to tell people what I think they should do, try to understand the problems. And I think that it's very helpful when we can have as many people in the family on board with the plan as possible. So I encourage in those visits mom and dad and siblings to come and understand what's going on with that person, that young person. But it's a very good question, very special attention. And of course, one question that comes up is, what things can or can't that individual, that young person, what can they, they're thinking about maybe vocation, career, right? What are they going to do in the future? What things can and can't I do? There's a lot of anxiety, fear around, maybe I'm not going to be able to do the things I want to do. The truth is, so much is changing all the time in our society, the way we interact with technology, in our jobs, in our roles, and the way that assistive technologies can help us do those things, that there's so many more opportunities for young people to accommodate to parts of their vision that are lost than there ever was before. I think it's important to remind parents as much as young people that things might be very different for someone with vision challenges now in the 21st century than it would have been for them in their generation, growing up.
Absolutely. And I think keeping in touch with Fighting Blindness Canada, real sense of community as we start to roll out more community events where you have opportunities as families and young people to get together, share suggestions, ideas. So be sure to stay in touch with Fighting Blindness Canada because there's a lot of great resources, not only on our website, but externally through events like this, and we can help each other. Sorry, Monica, go ahead.
Hi, thanks. My name is Doug. I kind of just walked off the street. I wanted to learn more, like really basic stuff. So I have a question about, they say understanding the problem is half the solution. So I have a question about we have the rods and cones, the photoreceptors. How much research has gone into the cells that connect to or are neighbors to these rods and cones, how they affect the health of the rods and cones? And what I'm thinking of is like if the rods and cones can be compared to our teeth, the cells beside would be like if somebody got gum disease. Or because the rods and cones are on the edge, the surface of the retina, these other cells are supplying their logistics, the food and nutrition for the rods and cones to keep them healthy. How much of that plays a role in rods and cones and longevity for them?
That's a great question. So for a long time, it was thought that the retina was very compartmentalized and that each individual cell type was really responsible for its own health. And when some cells were absent, other cells in the retina were just as healthy perhaps as they'd ever been. And certainly the evidence in support of that was really the fact that for patients with very specific genetic conditions that affect the health of the rods and cones as they disappear and diminish over time, we can still see many of the other helper cells, as you might call them, or cells that assist them in the retina, and that anatomy is generally preserved. We appreciate now that there are actually changes in the anatomy of those cells, that there's what we call remodeling or reconnection and rewiring that goes on amongst those cells after light-sensitive rods and cones disappear over time. But to get even closer to the point you're making, a lot of the new, as I mentioned, protective agents or new drugs and that are being trialed or that have been hypothesized to be helpful are coming out of research that looks at crosstalk and signaling between different cells in the retina, not just between light-sensitive photoreceptors, rods and cones, and there have been some molecules, neuroprotective molecules identified between those, but also between the other cells of the retina and the rods and cones. The retina is not just a living tissue that talks to itself through wiring and connections, electronic connections, the way we traditionally think of. Cells also release proteins, chemicals, and other factors that signal to each other through the extracellular matrix. They diffuse back and forth to each other, and they talk together. And some of those signals are important to regulate metabolism of the photoreceptors and encourage them to be very active. And other signals are negative ones and tell the cells to be quiet and to shut down and be silent. And by discovering those factors, we've been able to create potentially candidates for new drugs and neuroprotective agents, factors that are positive, that signal to the photoreceptors, hey, pick up the pace, pick up your metabolism, function stronger. And the hope there is that we can take sick photoreceptors that are still present, that are not as healthy, and make them work better and improve vision in that way. So I think that wasn't the first focus of attention in retinal biology, but as we've understood more about the biology of the retina, we've come to understand that those signaling pathways are much more important than we ever thought they were, or we ever knew they were. And that's maybe a plug, something important to say, that it's still important to understand the biology of the tissue that you have. And it's very humbling to discover new fundamental things about how the retina works, because it tells us we don't perfectly understand the system we're trying to treat and design therapies for. So I thank you for your question. I think we need to spend more attention on some of those basic biology of the retina to find new drugs.
That's fantastic. And that's why Fighting Blindness Canada invests in vision research like that Brian is doing, Dr. Brian Ballios is doing. So thank you very much for all your questions today. And thank you so much, Dr. Brian Ballios, for being here. We appreciate your time. And I know that the session's going to open up. So please stick around, have a coffee, and we're going to move into our next session. So thank you very much. And if you have any questions, Dr. Brian Ballios will be here for another 10 or 15 minutes. So come on up and say hello.
Thanks, Jamie.